Hi guys, I was talking to somebody today and said, hey, I saw a nonlinear analysis in another analysis code. Does SIMSOLID do nonlinear? I said, yeah, we do geometric nonlinear. So why don't we take the model that you saw and let's see if we can do it in SIMSOLID. So here's the model. This model is in Autodesk Fusion. We could also do it equally well from SolidWorks or Onshape, but here's a model. It's a thin metal strip, and although it's very thin, we're going to solve it as solids. So the way I do that, I just pick my little plug-in, open in SimSolid. Let's go into an empty project and bring it in. Now, the first thing I want to do is let's do a linear analysis. So I want to take just constrain this area here, so I can do that, and I'll use what I call a spot. Spot's an interesting thing. It allows you to specify a region of the model and constrain it. So that can be rectangular, circular, triangular, etc. But I just want to constrain this area of the part, just like that. So I can do that. Now it's constrained right there. Now let's also just add a real kind of a bending load at the end. So let me just come here and I'm going to put this small area there and put a vertical load in Y. And let's just do 1 Newton. We're going to solve it the first time just in a linear way. So there we go. Okay, so let's try to solve that. So I've got, I just hit the solve button. You know, I don't have to mesh. I don't have to do anything like that. It will solve it adaptively 3 times. And it's done. So let's look at our displacements first, maybe a deformed shape. Now, a couple things. Since we're going to solve this nonlinear, I want to look at the true scale, not just the exaggerated scale. So I'll pick here and I'll say show it as not scale deformation. So that's the true scale for this model. Okay, so why don't I take that and save that so we can come back and look at that later. And then maybe let's also go up here and save some stresses as well. So let's just pick the maybe a von Mises stress plot, look at it deformed like that, and we'll save that. Okay, well, let's, so there's the linear analysis. Let's try to solve this nonlinear. That's really easy to do. I'll just go back here. I can right-click on my linear analysis and I can say copy to nonlinear. So this will create a nonlinear, geometric nonlinear analysis with the same loads and constraints. Now, I could just run it, but I want to do one small thing. I want to double-click there to edit that load. Let's make it a little bit bigger than 1 Newton. And let's make it what we call a follower load. Now, a follower load will stay normal to the location. It won't stay in Y, but as the part bends, it will follow that bending. So we want to do that for nonlinear. So follower load, and we're good to go. So let's run that. Now this is geometric nonlinear analysis. It's still small strain, but it's large deflection. So there is our deflection on the linear, and here is the resulting deflection on the nonlinear. So you can see we get this nice exaggerated bend. That's the true scale deformation. In the same way, here is the stresses. You can see the stresses are concentrated down here. Here are the stresses for the nonlinear, and they're more up in this area. Well, we can do this again. Why don't we just run one more nonlinear? Let's just copy it, edit it one more time, and let's just make the load a little bit bigger. Let's make it 200 newtons. So just see what that does. And we can run that. You know, since SimSolid runs these things very rapidly, it's very easy to play around and say kind of a what if I change these things. So there we go. Here's our displacement there. There's the first nonlinear, there's the second nonlinear. Okay, well that's pretty cool, but why don't we do one more thing? What happens if we change the geometry? Well, this is a 2 millimeter thick section. What happens if we make it a little bit thinner? So we can do that really easily. We have to go back to our CAD system, so let's go back to Fusion. Let's go edit the geometry, and we can do a push-pull or something, but the easiest way for me is just to kind of double-click in the history and say it was 2 millimeters. Let's just make it 1 millimeter. So it's a little bit thinner now. And now I can go right back into SIMSOLID just by picking this button again. But this time, let's go into the same model. Okay, so I do that. Now there's a nice thing that happens here. It comes into the model, but it also copies down. It knows, well, we've already got analysis, defined here. So let's make a second design study and let's copy everything down. So I have structure 1, nonlinear structure 1, and nonlinear structure 2. So all I need to do now is run them, and I can just pick that and run all three at the same time. And you'll know it's run when you see the little result icon in the tree. So I've run the first linear analysis. There's the first nonlinear. And here goes the second nonlinear. Okay, so now I've run, just to summarize, I've run 2 linear analysis and 4 nonlinear analysis, all large deflections, small strain, on this model with 2 different geometric configurations. And I can look at, there is my first linear analysis, there is my second linear analysis. And you can see, since it's a lot more flexible, it's half the thickness, it's a lot more deflection as you expect. There is the nonlinear for the thicker part, there is a nonlinear for the thinner part. And again, we can even go back there and look at the 200 Newton load there and in there. So, very quickly, what I've done is just playing around, but I have done 2 linear analysis, 4 nonlinear analysis, 2 different geometric configurations, all in a couple minutes in SIMSOLID. Okay, thanks for listening.